Okay, so AppArmor. My name's Josh Marsh, and I work for Optum, which is a healthcare company, and it's actually a part of United Health Group, United Healthcare, and so they're big on security, right? Healthcare, huge security stuff. And so I know a little bit about this stuff. At work, my familiarity is more with SELinux, although I don't have to deal with it too much. But what I prefer to use is AppArmor, and so we're going to talk about that today, and just LSMs in general and what they are and what they mean. So hopefully that will make sense to you. But here's what I want to talk today about: the history of LSMs, so how they came about to be, and then how do they work, right? So what are these LSMs? You may not even know what they are at this point. But then why you should use AppArmor, and then we'll kind of do a demo of actually using AppArmor and getting into it, and then we'll have a Q&A. But for this whole thing, feel free to ask questions. If I'm saying anything that doesn't make sense or that interests you, you want to dig deeper, don't hesitate to ask. I'd be happy to, answer questions or tell you I don't know. But also, here's the link to the slide too that you can use. I kind of wanted to make this a good resource for you to come and a point to learn more about this stuff, because it's hard to talk about all of the features of an LSM and really understand the security around it in just 45 minutes or an hour or whatever. So when you get home and you're interested, there's a bunch of links here that you can click through and look at, and that stuff will be useful. So let's talk about the history of LSMs. And the term LSM, I'll use it a lot. It stands for Linux Security Modules. And it's basically, at a high level, just a way for the kernel to make system-level decisions about who can do what and when they can do it, right? And it actually started out in 2001 when the NSA introduced SELinux at one of the conferences. I think it was one of the it wasn't a DEF CON, but it was one of the conferences. Anyway, the link there is to their actual presentation. And so what they wanted to do was actually incorporate SELinux into the kernel, make it part of the kernel. And they had, they actually had patches and stuff that would put it right in the kernel. And Linus Torvalds, the inventor of Linux, right, in a fashion befitting him, said no. Make it a module, right? He wasn't interested in including this in the thing, and I think as we look now, that was a really good decision, because it's allowed different types of security modules to come out and fit the mold of people who are of what your use case is. So he said no, and then Crispin Cowan, who's I don't know if you guys are familiar with him, but he's pretty popular in the kernel community and all of this stuff, and he proposed the Linux Security Modules framework, which is you can see in that second, or that link right there, the first link in that bullet point is the original email he sent, and he came up with this idea. Here's how we should do this modular thing, a kernel module, so almost immediately the community got together and started building this and incorporating it into the kernel. And it was just a couple of years later, in 2003, when the LSM officially made it into the kernel. So that's like really a real brief history of how LSMs came to be. And before we talk about them, what the LSMs are, I kind of want to talk about the difference between discretionary access control and mandatory access control. Has anyone ever heard these two phrases before? Do they sound familiar at all? Okay, a little bit. Most of you, if you've used Linux at all, you're probably familiar with discretionary access control. It's the idea behind it is that the user decides, the owner of the file or whatever decides who can access it and who can do what with it, right? So these are the typical commands, right? The chmods and the chones. We say, okay, we're going to let everyone read this file, or we're going to let everyone execute this thing, or connect to this socket that I'm listening on, or whatever, right? The user decides in discretionary access control. And mandatory access control differs in that it's the system that makes those decisions. So the system, the user says, hey, I want to access this file, and the system says, you don't have permissions, you can't do anything about it. And there's not really, in the user space, there's not really a user or anything that can change that, right? It's the system that's making those decisions. And that's the idea behind these LSMs, is to say, I want the system to make a decision about what an application or what a user can do, so that if anything happens to the system, or so that if anything bad happens, I can prevent it. I can prevent a user from doing something bad. And here's how it works. I don't know how familiar you guys are with the way the kernel works or anything like that, but this is pretty simple to read through, I think, is when you're using your computer, right, you're in this normal user space, and at some point your application is going to make some call to the system, right? And this could be anything like reading a file, wanting to open a file, or connect to something on the internet, or listen for something on the internet, right? And the kernel goes through all these steps to do these checks to make sure that it's okay, right? And one of the checks it does is those DAC checks that I was talking about before. So it says, does this person have permission to do that? And that's an important thing to remember when you're implementing these LSMs, is that it still does these DAC checks, right? So if Apache doesn't have the correct permissions to write to a directory or to read from a directory, no matter how you implement your LSM, your security module, it's not going to affect it, right? Because that initial check is going to fail. But after that succeeds, then it looks at this LSM hook, right? So it says, is there a security module installed? And if there is, I'm going to ask that security module if it's okay for this application and this user to make this system call. And at this level right here, it's actually pretty simple. It just passes a thing and says, hey, can this user or this application do this? And it says yes or no. And if it's yes, it goes through. If it's no, usually get something along the lines of permission denied. So we'll kind of see how that works. But the idea of making it a module and adding this little LSM hook here, I think was a really smart idea from Cowan. And instead of just totally adding all of this stuff to the kernel itself and allowing it to be modular this way, is a really cool feature because it eliminates a lot of the work involved in the kernel space, right? The kernel really just makes one call to this thing and gets a reply back if it's okay or not. And so that's one of the reasons why I think using SELinux or these AppArmor type things is really useful, is that there's almost no overhead. It's a quick query, can it do this, and it's a yes or no. So from the kernel perspective, there's not much going on there. But it has a lot. It's a great way to do what the security people call complete mediation. So I don't know how familiar you guys are with security guys or lingo, but the idea behind security is to put up a bunch of walls all over the place, right? Not just one giant wall, but many layers to protect yourself, right? And these Linux security modules are another way to do that, to add this mediation to protect you, right? And so you have this other layer, and it costs almost nothing to do it. It almost seems silly not to be using it, especially in like production environments or financial institutions, anything where you need to protect yourself, your company, or your data. And it changes the model. It flips it over, right? So the applications require explicit permission to do something, as opposed to users deciding what applications can do. So you have a predefined set of rules. In AppArmor's case, they're called profiles that say you can do this or you can't do this. And so that explicit permission really goes to locking down the system, and I'll show you how that works. Makes it really helpful. Let's see, the other thing is anomaly prevention is another thing they talk about in the security group, and that basically just means you don't really, no matter how hard you try, you're going to find that there are issues with your application. No matter how much you've done to protect yourself or your application, you're going to find that someone's going to find a way to get into it or try and break it or is looking for ways to get through to it. And this is just another way for you to block against that, right? We've especially seen recently, right, some of them, sometimes it's not even bugs in your code, but it's bugs in third-party software, right? So this Heartbleed bug, that was OpenSSL, which everyone uses, right? So it was not anything that necessarily you did per se, it was just using a library. So this anomaly prevention, protecting yourself from these edge cases that you aren't aware of or may not even have control over, the LSM is a great way to protect against that. Even though I say common vulnerabilities, but hopefully you don't get a lot of these in your code, remote execution or directory traversal, it's really easy at solving those problems because it says, here's what you can do, here's what you can't do, here's what you can access, here's what you can't access. So why use AppArmor? Why would I pick AppArmor over the other applications? For me, the easy answer is I just use Ubuntu. Ubuntu comes with AppArmor. It has a whole bunch of predefined profiles that make it easy to use. So why fight an uphill battle, right, of trying to get SELinux to work on AppArmor? And so if there's one thing you can get out of this, if you say, okay, I'm going to start looking into this, I want to start securing my systems or playing around with this, the first thing I would suggest is use the one that your distro supports. So from the RHEL people or any of those ancestors, like CentOS and whatnot, theirs is SELinux. And I'm not a fan of SELinux, but you're probably going to have an easier time figuring out SELinux than you are porting AppArmor onto RHEL and getting that to work like that. So, yeah.
So we have things like discretionary access control, and then we have LSM. Is it that discretionary access control is a subset of LSM, or are they two
different things? Yeah. So the question is, like, what is the difference between, or how do they work together, this the discretionary access control and these LSMs? So think of, they're two separate things, right? One is a DAC, a discretionary access control, and the other is a MAC, a mandatory access control, and they are both separate checks on the system. So they kind of work separately. Sometimes there's overlap, right? I mean, depending on how low you want to go, DACs are in some way are mandatory access because the system makes those decisions for you. Even though some user has said, here's how it works, the system is still the one enforcing that, right? But they tend to separate it as who's making the decision about what happens, and in mandatory access or these LSMs, it's the system that's making the decision. So right here, when you have these DAC checks right here, this is when, like, for example, you want to write to your home directory, right? You have permissions to read and write to your home directory, and that's where this check comes in right here. But the mandatory access control, or where the Linux security module comes in, is another additional check, right?
Got it. So LSM is equivalent to mandatory access.
Yes, those are equivalent. The LSM is an implementation of mandatory access control.
I'm an SELinux guy, and you can correct me if AppArmor is different than this, but in SELinux, when you're talking about mandatory access control, it's all defined in policies. So you can say Apache, running as a process, can only access these things. And so that's part of the policy that's defined for Apache. And that's an example of how the mandatory access control works in SELinux.
Yep, and it's pretty much the same with AppArmor. They just use different terminology. It's profiles in AppArmor. But yeah, so what it is you have some predefined set of rules that the system uses to enforce or to protect itself from applications going awry or doing something it's not supposed to.
And so when you need, say, root access access to edit any of your system files in your root directory. That is LSM, or mandatory access control. That's sort of the most clear example of it.
That's still discretionary access control, right? Because what the Linux kernel has said is, if you're the root user, you have access to everything. And so it's kind of this discretionary access of this root user is a special user that can do whatever you want. Because with LSMs, you can actually, in fact, I can talk about it right now, you can protect applications running as root. So you can say, even though this application is a root user, I'm still going to confine him to what he can do. So an example of that, and I don't know exactly how NTPD works, the Network Time Protocol daemon, but it needs to be root at some point to change the date, right? It's querying every so often, whatever it is, 500 milliseconds, 5 seconds, whatever you set it to, right? And at some point it's going to say, okay, my clock is skewed enough and I need to adjust the date time. It has to be root to do that, right? So I don't foresee this ever being a case, but if it were possible for some user to maliciously modify NTPD, it would then have complete access to the system as root user, right? Because it's technically running as root. What you can do with an LSM, though, like SELinux or AppArmor, is you can create that profile, that mandatory access, and say the only thing that NTPD can do is make an outbound connection to some server and change the date.
Got it. So it provides a whole bunch of different flavors of root, essentially.
Yeah, in some respects, yes, yeah.
It allows you to define very explicitly what a process can do and what it can access, regardless of who the user is, even if it's root.
Right, yeah.
It can only access this file, it can only make this kind of a network connection. That's what.
Got it.
So I'll show, yeah, go ahead.
Is the opposite also true if I'm a non-root user, but I need root access for certain specific functions of my program, that I can say, all right, this process running as Joe is root for this particular access?
So there are these, I mean, I'm not going to get into the discretionary part of it where modifying the root, but in the Linux security module framework, and especially AppArmor, you can do a thing called change hat, which I'll show you in, well, I guess I won't show you, but you can basically change the privileges of an existing process temporarily to kind of do those things. But in general, that's not commonly used. For most cases like Apache or whatever your typical web server is that you're using, you'll basically say, only allow it to read from this directory and listen on this socket, and then and write to these logs, right? And that's essentially all you want Apache to do. And then from that point, you know, you're protecting Apache, right? So does that make sense? Did I answer that right? But yes, that's not an uncommon thing to do, to escalate privileges in Linux, right? And you can do that other ways. From the position of AppArmor, you can even change profiles temporarily, which, I mean, if you're really interested, I can show you later. So, okay, so some other reasons why I like AppArmor, and if you know anything about SELinux and I say something that's not correct, let me know. But one of the things that I like is with AppArmor, using the profiles is really simple. Is you have these profiles that say, here's my Apache profile, here's my Firefox profile, here's my special application profile. You can easily enable and disable them, things like that. It also focuses on the application themselves, right? And by default, it whitelists everything. So any application that doesn't have a profile can do whatever it wants. And I believe the default for SELinux is the opposite. Is that right? The default is everything is blacklisted. You can't do anything unless there's some explicit policy that allows it. So I tend to like that because I can say, when an administrator gets on the system, I don't necessarily care what he does, but for my external applications coming in, I'm really interested in what Apache can do. So I'm going to make sure Apache has a profile and is not doing anything bad. But when you know, the system administrator gets on and wants to change the data or whatever, I'm not really concerned about what he does. But the biggest thing of why to pick AppArmor over SELinux, I'm going to tell you, is really, again, the distribution you choose. If you're using RHEL or CentOS or any of those, it's going to be a lot easier to use SELinux, mostly because they've already defined most of these profiles for you. So it's the way we use it at work. The reason I don't know a lot about SELinux is because RHEL has almost done most of that work for me. I just install the profiles and say, I'm running Apache on this service, and it takes care of it for me. The same thing with Ubuntu. They have a bunch of packages that make it really easy to use, and they have common ones like Apache, and they even have a lot of, I'm not sure if SELinux has like desktop type ones, but with AppArmor you can confine Firefox and sandbox it, meaning, you know, if not that everyone is using, you know, not that, I think most people using Linux are a little bit more tech savvy, but if you're accidentally clicking, you know, the Viagra ads or whatever, and you can confine Firefox to protect yourself, right? So you don't have any problems.
Now, SuSE
Yes, SuSE also uses AppArmor by default, and they actually have quite a few tools for it as well. In fact, one of the things that, here's kind of like this high-level overview of how AppArmor works, and I believe it may just be in the enterprise stuff, but they have like reporting and alerting built in. So if you're using SuSE or you're thinking about deploying this at an enterprise level, it may be worthwhile to do that reporting and alerting, because you can kind of like watch all of your profiles and logs at once, and it reports all the errors to you in a cool little interface. But I haven't actually used that, but from what I understand, it's a cool feature. And since I stole this slide from SuSE, that's why that's there. So, okay, so like I said, you have these profiles, right? And they could be any application that's running on the system or whatever. That's how AppArmor uses the system, or that's how AppArmor kind of works at an application level, like I said. So you define profiles for your applications, and those profiles give the permissions that you're interested in, or that you want your application to do. And so up here you kind of have all these little AppArmor tools that are used to help you create those profiles, enable those profiles, manage the system. And those profiles get built into a sort of I don't know, a policy list that the AppArmor module itself uses, and then that hooks into the LSM interface that we were talking about before. So then when your desktop application makes a system call to the Linux kernel, it will query this, which will, the AppArmor module that will then consult the profiles that you've made, is kind of how it works. And SELinux pretty much works the same way, although I'm actually not familiar with how they do their policies and stuff. If they're, for AppArmor, they're just files on the file system. Is it the same with SELinux?
Yeah, although the files are really cryptic.
Okay. Yeah, I think one thing you'll notice about AppArmor is that it's a little bit more easier to read. I've looked at some of the SELinux profiles, and one of the things too is let me just first say, I don't necessarily have anything against SELinux, but so I've been to several conferences, watched several videos about SELinux, and it just starts, you know, my eyes roll back behind, you know, and I start thinking, what is going on here? Because you can do a lot with it, but the complexity almost makes it impossible to understand, at least for me, from my perspective.
SELinux is the send mail.
There you go, right?
It's incredibly powerful, but, you know.
Very cryptic. Yeah, okay. So here's some of the tools, and we'll work through them at all, but we'll work through some of them. The big ones I want you to think about is the AppArmor status. That's a great way to see what's happening. If you have an Ubuntu system at home, you probably have AppArmor installed, and you can run AppArmor status and see immediately what's doing there, what's there. I think by default the DHCP client is confined, so it's protected, and you can do that stuff. I don't really use the parser, but it's a way for you to load a profile manually into the system. Most of the time you'll use these three right here, the complain, enforce, and disable, those change the mode of the profile. Complain meaning don't actually reject a request if it doesn't fit the profile, but log it so that you know what's going on. And then enforce and disable would be, enforce means yes, reject, say permission denied, and disable means don't do anything. Another,
Complaint, sorry.
Yeah.
With the complaint, it sends you a message that they're going there, right?
It logs it in the system log. So it will say, this user tried to do this, and we would normally reject it, but you're in complain mode, so we're going to leave it alone. And SELinux does a similar thing. I think it's permissive mode in SELinux, where it basically says it's just going to log any errors that are encountered, but it's still going to allow it. And it's actually really useful for the GenProf tool, which I'm going to use, because it kind of scrapes those logs and figures out what your application was doing, and then you can create a profile from that. The one tool that I really like about AppArmor is this AppArmor Unconfined. And what it does is it scans your system for any network applications that are running that aren't confined, which in my mind is really useful, right? So you may have something running on there that you don't realize. You run AA Unconfined, and it will tell you exactly what applications. It'll say you have Apache running, but it's not being protected by AppArmor. Or you have this application you designed yourself, this Perl script or whatever that's running, that's making these connections or listening on a socket, and it is not protected. And so it's a great way for you to just kind of do a quick analysis of what on your system is not protected, especially if it's those front-end things, those web servers or web services, right, that are particularly vulnerable to attacks. Okay, so let's talk about the profiles, and I think the easiest way to do it is just to kind of show you. So let me do this little demo. And I think hopefully you'll see how, you know what, I need to switch like this so I can see. Sorry. Am I up there? Okay, so what we're going to use is that I made this little, can you guys see that, or do I need to make it bigger? Okay. Oops. So I have this little Dropbox clone that I created, and I'm going to kind of walk you through the process of what I would do to create a profile, and hopefully you'll see what the profile is, right? So I'll start my little Dropbox clone running, and it's just a real simple web app. And if I go back to it, here's my web app right here. You can see it's basically just a page, and it has all these things. These are all the files I've uploaded. I can click it and download the file, or I can come over here and upload a file, right? So I'll drop the file here and upload it, and then it shows up on my list. Where's one that I haven't done yet? Here's a mouse. So I have all these little images I'm saving, right? So it's a real simple Dropbox thing. Basically, I just save files there. I can get files, right? The problem is I've intentionally not done anything security-wise with it. So you can see here I'm doing these gets and posts to get files and save files. But it is not, it's doing that directory traversal that I was talking about. It's not sanitizing the file that I'm requesting, right? So see, I'm doing all these .. right, to Etsy passwords. And if I do that, I can actually get Etsy passwords, right? So you can see right now it's allowing me to get to that etc passwords, but generally isn't a good idea if someone can get to your entire file system, right, through that. The other thing I can do is, because it's not checking the file name, I can store files wherever I want, right? So here I'm storing it up a directory. So as opposed to storing it in the files where everything's done, I'm saving it one directory up. So there I've saved it, and if I look, it's uploaded the file, and then when I look right here, you can see the scary virus or whatever is right there, as opposed to in the files directory right there. And you could see that being a problem, right, is that anyone could upload their own version of your shell or your Apache or whatever, a modified version of Apache, and now you're hosed, right? So we need to protect against that stuff. And the easiest way to do it is to use AppArmor's GenProf tool, and I'll show you how that works really quick. It's just GenProf and then the name of the file that you are the name of the application you want to do. And you can see it's a bunch of stuff, and it's basically just saying start exercising the system. And so what you're going to do now is start playing with your system in a normal fashion, right? You probably don't want to be doing the buggy type stuff, but go to the system, play around with it, and then it will scan the AppArmor log for those events and kind of walk you through this process. So let's do that really quick. So here I'm going to download a couple files. Oh, oops, I guess I should start the application again, right? Let's upload one file too. Just exercise your system, right? So you could imagine if it was an application or whatever, you'd have some QA tester go in and play with the system for a little bit, or something along those lines. And then once you're done, you can go back to this profiler here and say scan the log, and it's going to start. You'll get used to it, but it basically starts printing out these things and saying, here's the profile I'm using right now. Here's the path that it asked for. So here it asked for this file's path, and it wanted to read that file. And then it's going to give you some choices. What do you want to do with that? And so in our case, we don't want to do the glob, right? We want to confine it to this one directory. So we select one, and then we select allow. Okay, now it wants to access files within the directory, right? It wants to read permission on files within that directory. So that's this one right here, which is one, but we don't want, it's not just that one file, right? We want to do all files, and so we do the glob. We say glob it, and it creates this right here. So it's saying anything in that files directory we want to allow. So hit A. A. So now it's found the static directory, and this is my web. This is our website code, right? The HTML and whatnot, and that's we just want it to be that one folder, and we want to allow it. But I have all these different files and folders, right? I have Bootstrap running. I don't know how much you guys know about this stuff, but it's a Bootstrap app, and so I want to allow everything there. And the way you do it is you can just keep globbing. So in this case, I'm going to say glob this twice, and I'm going to say, so anything recursively in the static directory should be allowed. And then I'll hit A. And so this is kind of this is just like a WebSocket thing. It's actually, I'm using Go. I wrote this program in Go, and Go checks this out. So I want to allow that. Otherwise, it won't run. And it's noticed, it's actually seen in the logs that it appears to be some kind of web server. And so it says, is it Apache that you're doing here? Do we just want to do the Apache? Or is it a DNS server? It has these include statements, right, which are kind of like default values for profiles. But in our case, we're not doing either of those, so we'll just do the INET. And the same thing with IPv6. We'll allow IPv6. And so now it will say, okay, we created your profile. Would you like to save those changes? And we hit save for yes and F for finish. And then our profile is ready, which is we can look at right here like this. And this is the whole profile right here, just those 10 lines or so. You can imagine that some may be a little bit more complicated, but not much more complicated than this, right? So I'll go over it really quick. The include statements are easy ways for you to include default type things that you may be doing with your system, right? The base is pretty common and used for almost anything. It's basic access to TTYs and stuff like that anyway. Then you have these, what are they called? Controls or whatever. And there's a special name for them. And I should get it right before I... Capabilities. So these are capabilities, and so we're saying this is a web application, so it's going to connect to these, to the internet, right? And then here's our file listings, and that's really as simple as it is, right? And that's one of the reasons why I like this, especially for like just a home use case or whatever. If you have a firewall that you're using for Linux or your own personal web server, or you have a cool little application you built in Node or whatever that you want to use, it's really easy for you to set this up, right? So it's just 5 or 6 things that I've set up, and they're pretty familiar, right? This one has read, this one has read-write access to this. The rest of these are read, and it took care of most of it for you. Yeah.
So just to make sure I understand what's going on here. So when you go and develop an application, you then call this program, which then says, okay, I'm going to watch everything coming out of this process.
Yes.
You go and put the process through its paces, essentially.
Mm-hmm.
And then it guides you back through the log of all of the files it accessed, and you say, yeah, that's okay, or no, that isn't okay.
Yep, exactly right. Yep, that's exactly what you do, right? So, and you could technically build this yourself with a text editor, right? You could go in and make it yourself. I just find the GenProf really useful because not only can you do it with applications you build yourself, but applications you're using, right? If there's someone's not already created a profile, or you're security conscious and are worried about profiles that have been created, you want to do it yourself, you can use the GenProf to do it for you, right? Load up Apache and PHP and check it out yourself, right? Even though you don't necessarily are making that source code or whatever. Or maybe you find someone's Dropbox clone online that you want to use. Don't use mine because it's insecure. But you find someone's little Dropbox thing and you want to use it at home for yourself. Run the GenProf on it and start seeing what it will figure out what it's doing, and you can create a profile to protect your computer from anything that might go wrong with that. And that's something that I think is really interesting, especially in the healthcare industry. My company has a big issue with open source software and free software and stuff like that. For some reason, to them, so I'm kind of like the red-headed stepchild in my company. There are other places that use it, but it's pretty much just my group that are the Linux guys there. And for them, the idea of something being free means, or a community-driven thing means that it hasn't been done professionally, right? Which isn't the case. But so for them, they want that added protection, right, when they're doing this other stuff. And this is an easy way to do it, right? Because we can do AA unconfined, and then we can do AA GenProf and create profiles for all of our applications or any of our third-party applications that we're using. And we know we have sandboxed that thing. We've confined it into something and protected the rest of the system from it. So, any other questions? Yeah. So in the capabilities, there's all kinds of capabilities, and so specific system calls can be confined. I believe you can even specify what ports can be accessed. It's almost like a firewall in that respect. All that is in the capabilities section, right? So you.
This particular tool you're showing us is strictly for configuring file access.
No, it will also do, the GenProf will also do your system tools, right? So if you were doing other things like yeah, so it discovered that you were using the network, and it said, hey, do you want to allow the network? So if you were doing this with NTPD or whatever, it would say, hey, you're changing the date. Do you want to allow that? And if you, whatever you were using, it would say, hey, I know you made this system call. Is that okay? Right? So, and I believe SELinux works the same way, right? I mean, any system call you make, essentially, all of these are system calls, right? Even access to files is a system call, and so it's protecting against all that stuff.
So given that AppArmor is included by default in Ubuntu now, does that mean that canonical supported software already have profiles
Not
for AppArmor?
Not all of them, but many of them do. So and many of them come by default unconfined. So Firefox, for example, and Chromium or Chrome, those actually have profiles. I can show you they have profiles, but by default they aren't confined. So
They're not turned on.
yes, so they're in complain mode or unenforced. So.
I was thinking second plane mode per profile.
Yes, per profile. So what we've said here is these Chromium things are in complain mode. These Chrome ones are in complain, and these ones are in enforce, right? So it's enforcing a profile for Java because Java is inherently destructive to your system. And so if for some reason you're using Java in the browser, it's going to confine it. But for these, the XDG settings or whatever is in complain mode, right? So it has different profiles for those different things. So you can see here, this one is now being enforced, right? The Dropbox clone that I made is now being enforced, which it normally sets up, but you could also enforce it with. Oops, what do I do here? So you would enforce it like this, and now with this application running, I should get errors when I try and do this stuff, right? Because it's now checking, and you see I don't get my Etsy password back. And let me try here. You can see in the log you start getting things like this, permission denied, right? So that's kind of the way that it works, right? Now that it's enforcing, it's protecting it. And so, especially if you're, I can see a use case where if you're providing systems to students or whatever, or to someone, you may want to protect Firefox or Chromium or whatever and prevent them from going nuts on your system, right? We'd like to think that everyone's a good user, but most people just don't know what they're doing, right? Okay, good. Any other questions? The rest of it's just kind of boilerplate stuff. Here's some other tools. SELinux is another one that may be worth researching. It's the RHEL version. Tomoyo is another one made by I wish I could remember his name. He's a Japanese security researcher. And it's not a default in any distribution that I'm aware of, but there's good instructions on how to do it in Arch and Debian. And it actually has a cool tool that similar to AA GenProf, where it will generate profiles for you, but you can put your whole system into this watch mode, and it will create profiles for your entire system, and then you can kind of go through and pare down what you want your system to do. Some other things that may be worth researching if you guys are interested in this stuff is C groups, which originally came out of Google with their App Engine stuff and their VM type infrastructure. It was originally used for resource limiting and reporting, right? We only want this application to be allowed a certain percentage of the CPU or whatever. But with namespace isolation, what it does is it allows you to add another container, another wall, right? So you have AppArmor protecting your system, and then you're confining the actual application you're running to its own namespace. So it can't see other programs running. It can't make other calls to other programs and stuff like that. And Docker is a really cool tool that makes using C groups extremely easy that I would definitely look into if you're interested in this stuff. What it does is it creates those containers for you. It kind of think of it as like a green version of like virtual machines, or like a light version of it. As opposed to actually allocating resources to a VM, it just provides like a file system and structure, and then it creates that C group, and it can do whatever it wants within its little container, and it uses whatever resources it needs from the system, but it can't get outside of that container, so it can't be reading or writing files outside of the container. It's stuck in that little chunk. And that makes it real, and I think that's a really cool tool. That's something to look out for. That's gained a lot of popularity in the last year or so. Here's a bunch of links. You can read more. Here's we talked about like default profiles. Ubuntu has this AppArmor profiles, and it's also it works for Debian too. But those are all those defaults, right? Like I keep saying this, but Firefox. All those ones that you use. I think it even does like the Evolution Mail client and stuff like that, right? So great way to profile. Here's the change hat, which someone was talking about. It's actually it's a C library, but I'm pretty sure there's a Perl module for it as well. And basically what it does is it allows you to do that privilege escalation like we were talking about before, where you say, by default, I only want my application to do this little bit, but in some special case, I need to, in this section of code, I need to jump out of that and be in a more versatile profile, so I can do some other things and then come back to where I was originally. And Apache actually has a mod AppArmor, and there's a PAMArmor as well. Both of those use this AA change hat, so you can control those things. I don't know. I guess I don't know many of what your guys' backgrounds are, but if you do a lot of programming or a lot of IT stuff, these might be useful in protecting whatever applications you're maintaining or administering or programming. So here's a great presentation by Crispin Cowan about AppArmor at DEF CON. And if you watch it, it's pretty clear that he hates SELinux. So you may end up joining the bandwagon. I don't know. I tend to be a guy of use what's easiest, and so I not really picked a side. But that's it. Any questions? Anything else? Okay. Thanks, guys.